Now, a bar shown in figure is subjected to a tensile load of 150 kN. If the stress in the middle portion is limited to 160 Newton per mm square, so that is, this is the portion wherein the stress is to be given. Determine the diameter of the middle portion. Also, find the length of the middle portion if the total elongation of the bar is 0.25. So the data given here, a bar is subjected to a tensile load of 150 kN. So P is given, capital P is 150 kN. So here I need to convert this into Newton, so that will be equal to 150 into 10 to the power of 3 Newton. If the stress in the middle portion is subjected to or limited to 160 Newton per mm square. 160 Newton per mm square. Determine the diameter of the middle portion. So we are going to consider the diameter of the middle portion as d2. Say for example, take this. So it need to be found. Also, find the length of the middle portion. So that means what should be the length between these two. The length of the middle portion which I need to find out. So now, here we consider this as L2. Now, first consideration, now he says the Young's modulus of the total elongation of the bar. So the total elongation of the bar is 0.25. So elongation, that is basically because we are applying a tensile load, that is 150 kN on this side and 150 kN on that side. So the total elongation delta L is given to be 0.25, and also the Young's modulus 0.25 mm, and also the Young's modulus is equal to 2 into 10 to the power of 5 Newton per mm square. So this is the data given, and also the length of the middle portion I need to find out. So now we will go to take up this problem. So first we need to find out the diameter of the middle portion. So that is, we need to find out the diameter at this particular portion. So but we know the stress here. The stress in the middle portion is given to be 160 Newton per mm square. Therefore, first condition, the diameter in the middle portion, diameter in the middle portion we need to find out. So how to find out that? So we know the stress. So he has given the stress value, that is sigma. So once we know the value of sigma, we know the load which is applying on this member, which is the tensile load, which is uniform throughout. So naturally P will be equal to 150 kN. And but we don't know the area of cross section, but the area of cross section, that is the one which we need to find out. So but we know sigma. So stress in the stress is given by sigma is given by P by area of cross section. P by area of cross section. Therefore, stress in the middle portion is given by sigma is given by the load by the area of cross section, that is sigma 2, which will be equal to P by A2. So here sigma 2 is given by 160 Newton per mm square, which will be equal to P, which is given to be 150 into 10 to the power of 3 divided by the area of cross section, which is given by pi by 4 into d2 square. So that will be equal to, therefore the diameter of the middle portion, diameter in the middle portion d2 will be equal to, the value is 34.5 mm, 55 mm. So this is the answer, 34.55 mm. So the next is the length in the mid portion. The next condition or the next variable which we need to find out is the length in the middle portion. Second condition, length in the middle portion. Middle portion. Let L2 will be the length of the middle portion. Let L2 will be the length of the middle portion. Length of the middle portion. Therefore, total length of the middle portion or total length in the end portion, total length in the end portion, will be equal to 450 minus L2. So that means you have total length is 450 minus L2 will give you this distance and as well as this distance both. So that is the reason why he says that it is the total length in the middle portion. So that will be equal to, therefore now we are going to apply the formula. The total extension will be equal to the individual extension of the each bar. So that will be equal to So therefore total extension delta L will be equal to total extension delta L will be equal to, so what is the total extension which will be equal to length of this plus the extension of these two plus the extension of this. So we know because here the diameter is same in both the sections and also we know the load is also same, and since the diameter is same, so the area of cross section will going to remain the same, the load is same, the length will also remain the same, and the Young's modulus is the same for all the material. So that is the reason why, so we can take it as P into total length will be 450 minus L2, 450 minus L2, then A1 into E. So this is going to be the total extension of this and as well as this both. Then we have the extension in the middle portion that will be equal to plus P into N2 into A2 into E. So therefore that will be equal to total extension is given to be 0.25, which will be equal to the load is 150 into 10 to the power of 3, 150 into 10 to the power of 3 into 450 minus N2, 450 minus N2 divided by area 1. Area 1 is pi by 4 into the diameter is 100 square into E 2 into 10 to the power of 5, that is plus 150 into 10 to the power of 3 into L2 by A2, that is pi by 4 into 34.55 the whole square into 2 into 10 to the power of 5. So now which are all the common factors here? Here the common factors are, one is 150 into 10 to the power of 3 and then 2 into 10 to the power of 5 into pi by 4. The rest of the things you will be inside. So that will be equal to 0.25 will be equal to 150 into 10 to the power of 3 divided by pi by 4 into 2 into 10 to the power of 5 and then open the bracket that will be equal to into 450 minus L2, 450 minus L2 divided by 100 square plus L2 by 34.55 square. So this is going to be the expression, and then after calculating this, so we will going to, after simplifying this, now we are going to get this, that is 0.268, 0.2618 will be equal to 450 minus L2, 450 minus L2 by 100 square plus L2 by 34.55 square. So on simplification, therefore the length of the meter portion will be equal to, that is L2 will be equal to 293.862 mm. So this is going to be the final answer.